Hi, this is Vignesh from Advanced Quality Center. Now we are going to discuss about magnetic particle testing, which is a surface and subsurface defect detection method. Magnetic particle testing, MPI, is a non-destructive testing method which can be used only on ferromagnetic materials. Ferromagnetic materials or materials with major content of ferrous or nickel, or cobalt, and their alloys. It can be simply said that MPI can be done on materials on which magnetic field can be induced. The basic principle of MPI is permeability difference and attraction of particles towards the flux leakage. Permeability is the ability of the material to support magnetic field. When there is a discontinuity which have less permeability, the magnetic flux lines cannot pass through the discontinuity. Therefore, it travels away from the discontinuity, and this causes a flux leakage outside the material surface. At this time, when we spray or flow magnetic particles over the surface, the magnetic ferrous particle gets attracted by the flux leakage. Thus, we can identify the defect visually. Remember the terms flux, flux density, Tesla, Gauss, Oersted, ampere per meter, and ampere per centimeter. Minimum of 30 to 60 Gauss is required for MPI testing, and this Gauss requirement can be checked using a Gauss meter or an Hall effect meter. Let us discuss about the magnets. Based on the property, magnets are classified into electromagnets or permanent magnet. Based on the shape, horseshoe, bar, or circular magnets. Electromagnets utilizes a current carrying coil wound over a steel substrate. Types of magnetic fields are longitudinal and circular magnetic field. Here, for MPI testing, we use either longitudinal magnetic field or circular magnetic field. And sometimes we use both the magnetic fields. Longitudinal fields are produced by method called coil short method, where a current carrying coil is winded over a ferromagnetic material. Circular magnetic field are produced by a current carrying conductor placed over a material which produces circular magnetic field around the conductor. Remember, the magnetic field which we produce identify defects which are perpendicular to it. When the defect orientation is parallel to the magnetic field, the defect cannot be identified. So it is essential that we induce magnetic field in both the directions. MPI can be carried out on ferromagnetic materials, but not on paramagnetic or diamagnetic or antiferromagnetic substances. effect of painting. Can MPI be done on painted surface? Yes, but remember, the sensitivity of inspection decreases with increase in the paint thickness. ASTM specification allows a paint thickness of 0.003 inch of non-conductive coating, and also it allows a thickness of 0.001 inch of electroplated surface with ferromagnetic substances such as nickel. Here for MPI inspection, we can either use an alternating current or a direct current. Remember, alternating current can detect only surface defects due to the skin effect caused by AC current. And DC current can identify subsurface defect. Be familiar with the terms permeability, susceptibility, retentivity, and reluctance. Permeability is the ability of the material to support the magnetic field, and susceptibility is the degree of magnetization of a material in response to the applied external magnetic field. Retentivity is the ability of the material to retain some magnetic field even if the external magnetization is removed. Reluctance is the opposition in the material to the magnetization. A low carbon material, that is, a material with carbon content less than 0.3%, have high permeability but low retentivity. A high carbon steel with the carbon content more than 0.8% cannot be magnetized easily. That is, it have low permeability but it has high retentivity. Let us discuss about the different types of MPI equipments. For longitudinal magnetization, the equipments are coil and yoke. For circular magnetization, the equipments are headshot, rod, and central conductors. Here is a picture of headshot machine. It is also called a bench type equipment or an end-to-end conductor. Here are the two movable headstocks with copper conductors, where the component is placed in between. There is a foot switch to apply the current. There is a black light or a UV lamp. There is a black light intensity meter. There is a digital ammeter and a darkroom setup. You can notice there is an additional setup called rigid coil. So here both longitudinal and circular magnetic field can be applied. When current is applied from this copper conductor to the other copper conductor, there is a circular magnetic field induced in the material. When the current is applied to the rigid coil, there is a longitudinal magnetic field induced in the material. Here is the second machine for circular magnetization. Prod. Prod machine have a portable transformer unit and a handheld copper conductors, which produces circular magnetic field in the material when current is applied. Remember, the minimum prod spacing should be 2 inches and maximum should be 8 inches. Central conductor method. Central conductor method is a method used only for hollow components, where a copper central conductor is held between two head-to-head conductors and the hollow component is suspended in the copper conductor. When current is applied to the copper conductor, the produced circular magnetic field passes around the component. Remember, a minimum of 3 rotations is required for complete inspections. Yokes. Permanent yokes. Permanent yokes are made of permanent magnets. Electromagnetic yokes. Electromagnetic yokes are made of soft piece of ferromagnetic materials with copper coil windings around it. Remember, the minimum distance between the legs is 2 inches and the maximum distance should be 6 inches. Rigid coil. A rigid coil is a setup with copper coil windings of 2 to 3 or 5 windings and the component is placed between the windings. Remember, the inspection will magnetize a total length of 9 inches from the center of the coil, and the inspection is applicable to lengthy components. The length should be 2 times the diameter for proper magnetization. If the length of the component is less, extenders can be used. Wire wrap coil, where a copper wire is wound around the component and current is applied. The current selection for wire wrap method can be found with the formula Ni is equal to 45,000 divided by L by D plus 2. MPI particles. MPI particles are ferrous particles of different colors. There are dry and wet particles, also fluorescent and non-fluorescent particles. The particle concentration can be checked using centrifugal tube method. The concentration should be 1.5 ml to 2.4 ml for 100 ml of visual suspended particles and 0.1 ml to 0.4 ml for fluorescent suspended particle. This concentration should be checked 8 or once, and also the standard allows a maximum of 30% contamination, which has to be checked during this inspection. Lighting. For visible particle inspection, natural or artificial light can be used with a minimum of 1000 lux light intensity. For fluorescent particles, black light or UV lamps are used with a minimum of 1000 micron watt per centimeter square intensity at a distance of 15 inch from the lamp. Field indicators. Field indicators are used before commencement of inspection to prove that the system for MPI inspection which we use induce the proper magnetic field in the material. Pi gauge, slotted strips, Keto's ring, shims or QQIs, quantitative, qualitative indicators. Both hole device, MTU test blocks, and gauge meter or Hall effect meter. Demagnetization. Demagnetization is not required for low carbon steels, but in the case of high carbon steels, due to high retentivity, demagnetization becomes essential. Demagnetization is removal of magnetic field that can be done by several methods. By heating above its Curie temperature, for example, for low carbon steels, for about 700 to 1300 Fahrenheit. Or it can be subjected to reversing magnetic field. The material can be moved near and away to a coil with alternating current, or simply using a yoke with alternating current moved near and away to a component, or by simply decreasing the magnetic field gradually when using a headshot method. Use field meter such as gauge meter to verify that the residual field is removed. This is a picture of a demagnetization coil which uses alternating current to demag the material. These are the crack indications of the inspected components using fluorescent method. And these are the indications in visible method. MPI standards. Thank you. I have shared a link to download the PDF in the description.